Okay, well, we're back to this part two of our video about comparing. All right, so we have our character 1 and we have our character 2. Now what we want to do is we want to use an if else to see if these characters are the same. Now, characters are primitive data types. So when you're comparing one character to another, it's not looking at the shape of the character. It's looking at the ASCII value of the character itself. Every character in the whole world has an ASCII value. Whether it's decimal, hexadecimal, or octal, it has a value. So let's do our first comparison. All right, so if, oops, if char 1 is less than char 2. All right, remember, this line does not get a semicolon. All right? If you put a semicolon on this line, you're going to get a syntax error, and it's going to be really, really, really hard to find it. All right? All right, so if this is true, I'm going to print out the statement system.out.println. Because char characters are primitive data types, I want this whole concatenation to be strings, so I have to do that trick. Quote, quote, concatenation, char 1 is smaller than concatenation char 2. Now this does get a semicolon because this is a executable line of code. Now we're going to do it else if. Now we're going to see if the two characters are equal. Equal, equal. I'm going to do exactly the same thing. Are equal. Or char 1 is equal. Let's use proper English. Concatenation char 2. Now we don't have to do another else if. We don't have to do another comparison because this is kind of a logic thing. All right? So if char 1 is not less than char 2 and char 1 is not equal to char 2, then by deductive reasoning, char 1 must be greater. So all we have to do is do an else. I mean, we could do another if else, but we don't have to do another comparison. Okay, and I'll put a little note here. By reasoning, we do not. By reasoning, we can conclude that it is greater. It's just logic, all right? So let's compile. Let's see what's wrong. Oh, I spelled system wrong. Spelling. Anybody else having trouble with spelling? All right, so we're going to run it. No main method. All right, we're going to handle that later. All right, so this is comparing our characters. Now let's go on to using strings, using compare to with strings. All right, so we need some strings. All right, we got to ask the user for some strings. So, oops, system.out.print enter a string. Okay, and we've got string 1 is equal to our scan dot next line, because we don't know how long it's going to be, right? And then we need another one because we're going to compare them. Enter another string. String 2 equals scan dot next line. Because we're using next line, we don't have to clear the buffer. Everything's okay, all right? So now when we use compare to, if one string is less than another, it returns a negative number. I don't know what the negative number is going to be. It's going to be the difference between ASCII values, and I really don't need to figure that out. It's too much information. So it's either negative if it's less than, it's 0 if it's identical, and it's positive if it's greater than. So I'm going to use that information. So I'm going to make a local variable. Int answer equals string 1 dot compare to string 2. Now I say this is a local variable because we have instantiated it within the program. We're in program. Are we in program? Oh yes, we're in program right here. Why is this doing? Public void program. Because we've established a variable inside program, it is a local variable, and its domain only exists within that program. We could use answer outside of it, and Java would not complain at us because it doesn't exist outside of it. All right, so now we're going to use the fact that this number is either negative, positive, or 0 to decide who's bigger than who. So we're going to do an if statement. If answer is less than 0, we're going to say system.out.println string 1 concatenate is smaller than string 2. All right? Else if answer is equal to 0, we can say that they're the same. String 1, concat, is equal to string 2. Now we don't have to do an else if because of the logic. If it's not less than 0 and it's not equal to 0, then by logic it must be greater than 0. So we can just do an else. Okay? So there's a so here's an extra step. Line 61. This is the awkwardness of this method, this string method. When you compare one string to another string, it's going to give you an integer answer. So then you have to set up your if, else, if in such a way to compare that negative, 0, positive number to 0 to decide what you want to do with it. All right? So that's that little extra step in there. Okay. I'm going to compile, make sure everything's happy. All right, everybody's happy. Now we're moving on. We're going to do dot equals ignore case. But we're going to do it a little bit different. We're going to introduce the not, which negates it. So we're going to see if something is not equal to. A lot of times when you're comparing a lot of stuff and you want to see the opposite, you're not looking for a particular value. You're looking for a value that it's not. It's easier to compare to do the opposite of looking for a particular one. It's much faster. Much faster. Remember, the faster program wins the contract. All right, so now, in this case, we're going to do if. First, we're going to do the positive way of doing it, and then I'm going to show you where the not goes, all right? If string1 dot equals ignore case, and over here we put string2. All right. So what I'm going to do is I'm going to be so bad. I'm going to borrow all this. All right. I'm so lazy. All right. So if this is true, all right, so what we're going to do, let me show you. To negate this statement, I'm going to put the exclamation point right in front. Shift exclamation point. So now this is going to look for if it's not equal to it. All right, so string1 is not equal to string2. And in this case, some of you are probably going crazy right now because I'm doing this. Is equal to. I'm jumping around too much. I'm sorry. There. Okay. So let's slow down a little bit. So if not string1 equal ignore case string2, so if they're completely spelled differently, who cares about case sensitivity? But if they're spelled differently, this statement right here, because the not false is true, so it comes down to line 73 and it will say it's not equal to. Else, if it's not equal to, obviously it is equal to. Does that make sense? All right. So this is how you use not. And this is how you use dot equals ignore case. If we took this part out, it would be case sensitive. It would be case sensitive. All right, so let's do our floating points now. All right. So we got to ask for some decimals. All right, so let's ask the user for some decimals. Enter a decimal. Then in dec1, scan dot next double. All right. Let's clear that buffer. And let's ask for the other one, because it's exactly the same wording except for one character. We're just going to copy paste. All right, enter, I guess we could say, another decimal. And this one's going to be dec2. Now, in our earlier example, what we do, 6.25 and 6.26, when comparing those two numbers, you want to know if the difference of the two numbers is greater or is less than or equal to our tolerance, right? Now, to do the difference, I don't have to do a really difficult comparison of if, else, if the negative or positive. So what I want to do is I want to take the absolute value of the difference. I just want to know if the difference, whether it's negative or positive, is outside of our tolerance. So what I'm going to do is I'm going to do a if math.abs, which is absolute value, I'm going to subtract them. Doesn't matter how you subtract it. You could do dec2 minus dec1, or you could do dec1 minus dec2. It doesn't really matter because I'm taking the absolute value. And as long as this is less than or equal to my tolerance, then this statement will be true. So if I want my tolerance for the 6.25 and the 6.251 and 6.252, my tolerance was out to the 10,000th place, this statement would be true. So now if it's within the tolerance, we're going to go ahead and say that they're essentially equal. Can't print today, type today. All right, essentially equal. And that means they're within tolerance of each other. They're close enough. Else, they're not. All right? If it's outside of tolerance, they're not essentially equal. Not essentially equal. All right, so let's compile. Okay, so we've completed all the comparisons. Has anybody noticed what's missing? All right. So we're going to learn something else today. This is a program that has no main method. See, if I push run, it says it has no main method, all right, or it doesn't have an applet. We'll learn about applets later. So we're going to learn about, this is a service program. It just provides a service, and you have to have another program somewhere else, a tester, something to test this with, to see if it works. And anybody can use this as long as your program, this program right here is public, and the program itself is public. We can create a tester that uses this program to run it. All right, so this is what we're going to do. We're going to do File, New, Java. We got some notes here. The program comparing tester runs comparing.java. Okay, this is the one that's going to run it. For the sake of time in the video, I'm not going to put my username in. We're just going to go right to it. All right. So public class comparing tester. All right, open squiggle bracket, close squiggle bracket, end class. And in here we need a main method. Public static void main. String open and close square brackets, args. Opens curly bracket, close curly bracket. So we got end main method. So up here, now, I want to use the constructor not from this program, but I want to use the constructor from my other program, comparing. So I'm going to make an object from that class. Comparing start, that's my object from that, equals new, and here's the constructor. Comparing object from other class. Now that I have start, I have an object from comparing, I can use start to access all the methods that are in comparing. Now I access it by naming the object, start, then I use the dot operator, dot, and then I do program. This accesses program in comparing. All right. Now, this tester, this is important. This tester needs to be in the same folder as this guy. So I'm going to make sure that I press the folder with B on it. So here's comparing. Now when I compile this guy, it's going to want me to save it. See, this is in day 14. So I got to make sure that I'm in day 14. I'm going to save it. All right, it compared it. Now, if I go to run this one, it says no main method. But if I go to run this one, when I run this, it asks for a tolerance. Now, how much, what do we want? How about 0.001? How about that? All right? Enter a character. I'm going to pick A. And I'm going to pick another character. I'm going to pick Z. Now, is A smaller than little z, or is A bigger? A is smaller than z. You know that. All right, so we're going to enter string. Thank goodness it is Friday. All right, we're going to another string. Thank goodness it is Friday. Now, which one's bigger? Is thank goodness it is Friday or thank goodness it is Friday? Which one's bigger? We're using compare to. Thank goodness is Friday is smaller than thank goodness is Friday. Now, the second one that was tested was ignore case. And because it was ignore case, thank goodness it was Friday is equal to thank goodness it is Friday, because it ignored the fact that this was a lowercase t. Now we want to end a decimal. Remember, we're going to be tenth, hundredth, thousandths within a thousandths. So we're going to do 3.1234. All right, so we're out to the 4,000ths. And then we've got 3.123. What should we enter? Do we want it to make it true or false? How about 4, 5? Are they about the same? Are we within 1/1000th? Yes, these two numbers are within 1/1000th. Remember, tenth, hundredths, thousandths. So they should say essentially equal, and it's true. There you go.